Folks, can you hear me, and am I louder or too quiet as compared to the music? Someone could give me a nudge, that'd be great. Reading the chats, can anyone hear me? Good levels, fantastic, thanks that Wolf. Too quiet, okay, so probably need to maybe wind the volume of that back down a little bit. Music could be slightly less. How about that? Maybe what I'll do, let me just bump that back up to that, and we'll... How about that? Is that better? Yeah, so hopefully you can hear me now. That's fantastic. Thank you for the help, guys. So I have actually changed my setup a little bit since the very last stream. There's a number of reasons for that, but I won't go into the details as of yet. But anyway, so I've got resolution changes and sound changes and host changes and setup changes and all that other lovely stuff. So hopefully this is all we'll need to do to figure out the status of things and make sure that everything's working for you guys. Thank you to everybody who's decided to turn up at such short notice. I felt the need to get into another stream for the first time in a long time, and yeah, we'll see how it goes. Wow, it looks like there's already a fair few of you around. So awesome, and thanks Justin as well. Justin's a mod. He'll be making sure that nobody's nasty behind the scenes. Fantastic. Someone's mum says hi. That's awesome. I'm glad they're watching. So what I'll do, I should flick the scene, shouldn't I, so that you can see my ugly face. Let's just move this to here. Hey, can everyone see me? Woohoo. That's probably a bit too big. Hey, I'll wind that back a little bit. How does that look? That should be okay. You don't need to see my face any bigger than that. Hey, so greetings all. Lovely to see you again. It's been a long time coming. But remember that everybody should be bringing with them a solid cup of tea. Hacking without tea is so uncivilized. Oh, this tea is fantastic. This is T2's Gyokuro green tea. It's very grassy. I won't say good friend Sean put me onto that tea, but it is seriously good. Okay, so quick check if everyone can see my screen and make sure that the resolution of the text here is visible and okay, and I don't need to adjust anything. And I'll flick over to this Win 10 machine as well and make sure that you can see that at the same time. So let me just make sure that I've got all silent. Okay, so what the Rob? Yes, the stream is going to be recorded for sure. I will archive it on YouTube just like I usually do. So good text size, that's fantastic. What else do we need to answer? Zoe Rose is behind you. I hope. Is she? Okay, so what I'm going to do is I'll do my best to keep my eye on the chat, but that's actually sitting on a laptop over here to my left. You notice that I've changed the camera position as well, so now you're like fully in my face. I will try to remember to look up and look at you every now and then. Could make the text a little bit bigger. So if I make the text too big, then I'll sort of start to lose real estate. So if it's an absolute issue, I will adjust it. If not, then can we do it? Maybe I can get some votes. Text look good to Gekem and Justin. Yeah, I've got this streaming at 1900 by 1080, and I've got a 4K monitor here. So on my screen, the text is bigger than my head. But I didn't want to do the dance of having text kind of jammed into tiny VMs and me strained to see it, but you guys kind of see it okay. I just wanted to sort of make sure everything's cool. Text is fine here, providing it's not one color. Yep, there won't be one color. There will be a mixture of colors depending on syntax and such. Okay, well let's move into it. Look, this is the first time I've streamed after setting up a means for people to donate, and I'm only ever going to mention this once. If you want to donate, please do. If you don't, then don't donate. It's seriously not expected. I just had a few people say that they wanted to help out by donating here and there, and it kind of makes it easier for me to justify spending the time and all that sort of stuff, but don't feel obliged by any stretch. Full details are on that on the Twitch page. So, and that's the last you'll hear of it from me. So what I want to do tonight is sort of get back into the swing of doing some binary exploitation stuff. What we're going to do is we're going to try to exploit an application called SyncBreeze. There was an exploit drop for this on ExploitDB a little while ago, and we're not looking at that. We just know that there's a memory exploitation bug in this app, and we're going to see if we can find it. We're going to explore a little bit. We'll try to do some reversing in IDA and follow our nose and play around in a debugger and that kind of stuff. So we're going to be doing this on the most recently updated version of Windows 10. My goal for this will be to go from nothing to hopefully getting to the point where we can control EIP. So if we can in some way control code execution, at that point, depending on time, we may stop. Depending on how long it's taken, we may continue if everyone's still keen, or sick of it, or if I've lost everyone and they're all bored, then I'll probably just stop. Maybe we can do that as part of another stream further down the track. So that's the plan. if we do have time, we will have a bit of a play to try and actually get a payload running. But you know, for all I know, there could be some fun mitigations in place with the latest version of Windows 10, which makes getting a fully interactive shell functioning painful. But you know, I'm not an expert. We're all here to learn, so hopefully you'll get something out of it, and please be nice to each other and to me. So, question: I have a friend who needs you to show him how to stream. Okay, that's fine. I'm guessing you're referring to Justin. Yes, you are. Alright, so what I've done is I've updated this Windows 10 VM and I've installed this thing called SyncBreeze. You can see that it's got a client application and it also has a service that runs. And so it's just a classic client server application. So when we run this client, we end up with this horrible looking user interface. I don't even know what this thing does, to be honest. But for the sake of full disclosure, I have had a play around with this thing in the past, and I just thought it would be a fun thing to stream. I didn't get payloads running or anything like that, but I did do some of the analysis, which I've long since forgotten. So this isn't all completely off the top of my head, but I'd say 95% of it will be. So don't expect to be impressed. Okay, so this thing connects to the client and server, and you can add commands. I actually don't know what this means. Let's go see if we can specify the same thing for both. Let's go. Source and destination are the same. Of course they are. Alright, so I can create a thing. I'm guessing that's to do with folder syncing or something. So anyway, so clearly it's doing some communications behind the scenes, and I would assume, given that this is a remote sort of execution vulnerability, that somehow you can talk to the server through whatever their custom protocol is, or whether there's post requests or some kind of REST API behind the scenes. When I set this up, there were two settings as part of the configuration. One of them was like a web port and the other one was a custom port. I don't know what that meant, but we have a look at netstat. Oops. Here we go. So we should be able to see it listing here. I think it's this one here, 9121 is the other port that it's listening on. It looks like the web part of it isn't actually running, it's only that one that's running. And if we fire up TCP view, we'll probably see that this thing is actually connecting. But what I'm going to do instead is I'm going to fire this up again, and we're just going to capture a little bit of traffic. Now, when I first tried capturing traffic, I had a bit of trouble because what I was doing was I was using Wireshark, and Wireshark was unable to capture anything from localhost. So when I chose this and hit start, right, let's minimize that, and I fired this up. Okay, we can see it connected and it got some bits and pieces, but there was nothing in here that looked like TCP traffic. So I was a little bit confused, and then did a little bit of reading and found out that Wireshark doesn't actually capture traffic that comes back on localhost. You've got to use something else to do that. So I asked a friend of mine by the name of Pelias, or Ryan, who lives down in Canberra, and he gave me this little hint that what you need to do is use a tool called RawCap. Oh, great. Just give me a minute. Clearly I need to install .NET Framework. So this is an older binary, and it needs to run .NET 2.0. So we'll just let that run for a minute. It shouldn't take too long. The connection here is actually fairly decent. Have we got any questions so far? This is clearly very complicated stuff. Good peoples live in Canberra. Yes, indeed. Used to be able to get Wireshark on Windows to capture localhost by installing the localhost adapter. Okay, I didn't know that. That's an interesting tidbit. Maybe I'll have a play with that a little bit later on. But RawCap, this thing here does actually do it on localhost. Bring out the .NET CDs. Exactly that. CDs, man, blast from the past. So once this is finished, we should be able to run rawcap, and it'll give me a bunch of options. Come on. What we're seeing here is the power of Australia's NBN. I do actually have fiber to the premises here, so this is this should be at its best. Is anyone having issues with the stream? Is it buffered at all? Because I'm also using the low latency setting in Twitch to make it work a little bit faster. I have one of these bundles. If OJ chooses, we'll get it. Ooh, wow! Everyone have a look at the chat, because Nothing But a Lurker is sharing a potential bundle. Pocket Primers books. The stream's really good. Excellent, thank you. Oh, come on, .NET. It can't possibly take this long. There we go. That's pretty funny. Let's just pull this straight down and see if we can install it straight from the web. Sorry about the delay. I should have actually put this in as part of my base installation, but as I said, like I redid my virtual machines and I forgot to run rawcat before I fired this up. So you get to really thoroughly enjoy the experience of watching me install the .NET framework. This is what people are subscribing to the live streams are out there to see. Sorry about this all. That's what happens. Come on. I did hit go, didn't I? Maybe I should allocate some more resources to this machine. New goal. Yeah, that's right. Let's move on. We're not looking to get rip control anymore. This time we're literally just trying to run a .NET installer. Didn't I run that? That should be running already. Where is MSI exec running? Yes. Come on. So, this is embarrassing. Actually, while that's doing its thing, let's have a quick look for Wireshark localhost adapter that capture setup loopback. Here we go. Is there a way of doing it? Windows Vista. Missing error. You can't capture on the loopback with WinPCAP. You can, however, use a raw packet sniffer like rawcat. There you go. So that's what we're actually trying to use. But for some reason, it's not playing nice. You also have to run rawcap as check that out. It worked. So clearly behind the scenes, the installer has actually finished. You heard it here first. All right, so I'm going to say we'll just deal with the defaults. I've said that I want to capture on the loopback interface, so 127.0.0.1. We'll just store it in dump file, and off we go. Right, so all I've done is run that connected, and now I'm going to disconnect. And now I'm going to use Wireshark to open ctools dump file. Okay, so here we can actually see some traffic back and forth between these ports. So hooray, we've captured some packets. So now we should be able to do some analysis of what's going on. What are we going here? Greetings, Kibai. Is it Kibal? Yeah, right. Microsoft Loopback is a device you can install this testing now. Oh, okay, that's good to know. Used to be Windows 7 probably changed things. Yeah, who knows? Windows 10 does muck things up a little bit. Anyway, so we can see a bit of a back and forth between the client and the server, and we're sort of interested in what this protocol's looking like. It does look like there's a little bit of a back and forth. Some packet sizes look kind of similar, like we're seeing a repeating packet size of 52 here. Maybe that's some kind of heartbeat or something similar. But let's just have a quick, ooh, here we go, this one looks interesting. So we can see here that there is a packet outgoing from the client to the server, and it says, it's got this server get info string in it. I would assume that the following couple of packets contain the results. And if we were actually looking at the client, maybe we could see some server information in here. Connected to admin or localhost. Doesn't seem to be any information here about what. Let's see what the about says. Evaluation copy. I hope you like my hostname. Platform 32-bit. So there's nothing here that I can see that sort of implies the version of the server. I would assume that there would be something in here that's interesting. There's nothing. Yeah. Anyway, we'll close that off again, and we'll come back to that. So we've got a message going out here that says get server info, and we're going to assume that this or this contains the response. So hopefully that we're seeing there. Look, it's pretty interesting. So the actual data in here looks like it's got some magic values, followed by other values here. So these like 0000001, 0000001A, 0000020, or even looking at swapping the endianness, it could be 30001000 1A 0002000. They could be integer values that represent something. So a lot of the time with custom protocols, there tend to be a basic structure that says, here's how much information I'm sending you, here's what type, and here's the actual data. I mean, to draw a crass correlation, the Meterpreter protocol has a very, very simple type length and value, although it's actually length, type, and value. So you get a 32-bit integer that specifies the length, 32-bit integer that specifies the type of the data, and then after that you have whatever the data is. And so a lot of protocols have that kind of stuff baked in. So I'm going to assume for the sake of this discussion that this is actually similar. So this server get info that starts here, I'm going to take a guess at this point and say this stuff, the stuff before it that leads up to this 0 here, is probably the header that describes some metadata, and this is actually the body of the message that comes immediately afterwards. Let's have a look at some other ones. Where are we? The inbound. There's no data in that one. There is some data in that one. That's 7919DC is the first few bytes, whereas this one is 7519BA. Wonder if there's any other ones. Ah, here we go. This 96. You can see here again. There's another one that's similar. It's got the similar starting header, slightly different values. Like there's a 0 there and a 9 there. But we may be seeing at least the basics of a packet header. These are all empty packets. There's another 96 there. Again, 7519BAAB. What else have we got? 176. There you go. That's a bigger one. Yeah, let me scroll that up a little bit so you guys can see it. So this magic value here, 7519BAAB, I'm going to take a guess at this point, and the first time I looked at this I did take a guess at this point, is to say that this is effectively a magic number that behind the scenes sends a packet down a particular code path, and that packet is parsed in a certain way. And we're going to analyze, or attempt to analyze, how that packet is handled. What I should probably do is try and fire the chat up in a different window so that I can see you guys when you're asking questions. Just give me a sec. I'm going to do that now, so that it's not over here on a different monitor. Close that one down. Here on a different monitor. There we go. Okay. Alright, so now I've got you over here so I can actually see the activity instead of having to constantly turn my head. Alright, so what I'm going to do, let's go back to this 96 byte packet, and we'll just get some basics together in a simple payload that we're going to send. I'm going to stick to this server get info and just see what it is that it sends back behind the scenes, right? So can we actually copy this? I don't think that we can. That's not too much of a concern. So what I've got here is I've just got a folder here that has one file in it, which I like to call exploit. It's going to be, we're going to write something in Python that's going to interact with this thing behind the scenes. Nothing particularly rocket science. I don't think there's anything in here that's going to be surprising to people. ABBA 1975, there you go. It's like magic integer value of ABBA 1975. That's a nice find, Justin. I haven't picked up on that. That's pretty funny. Oh hey, it's Waxwing's in. Hey Hex Waxwing, how's it going? 6:30 in the US. I'm eating breakfast while watching. Wow, you are committed. All right, so what I'm going to do is quickly throw again some basic structure together that's going to allow us to talk to this piece of junk on the port behind the scenes. So we're going to go user env Python. I like to use Python too, so come at me haters. We're going to use Pwn tools. So let's start with what we're going to have as the packet header. Now according to Justin, this is ABBA 1975. So we need to go hex 75. Oh man, there we go, 75. Hex 19, hex BA, hex AB. Yeah? I'm going to get sick of flicking between these tabs, aren't I? So 7519 BA AB. And then we seem to have what looks to be, I'm going to go say that's a packed integer. That's a packed integer, that's a packed integer, and that's a packed integer, and that's a packed integer. So I'm going to say there's 5 packed integers before we get to the data. Okay? So back over here in our exploit, I'm going to go header plus equals home.pack 32-bit value, and this could be, it's 5 of those. In fact, I should have done it this way. The Vim users out there are probably hating me, so I'm going to yank that and paste it 4 times. That's much more effective. Now, this first value, what was it? It was 3, 1, 1A, and 20. All right, so let's do the same thing over here. Come on. There we go. All right, so 3, 1, hex 1A, and hex 20. All right. Okay, so we're going to have a socket, and that's going to be plain.remote. We need the IP address followed by 9121. Now I think the IP address is only one less than the one that I've got locally, which you can see down the bottom of the screen here. So 192.168.20.1.2.28. Let's just quickly confirm that. Yeah, 128. Okay. Alright, so we're going to connect to that. At the end I'm going to leave it as interactive because I just like to have the socket left open until I'm done with it. And then what we're going to do is we're going to go, we actually need a payload, don't we? So, or we'll call it the body. Now according to Wireshark, the body contains server get info followed by, what do we got here? 02. Maybe that's some kind of delimiter. 02 followed by the number 2, 01 followed by data, 01 followed by data, 01, and then what looks to be some other gubbins at the end. perhaps everything sort of from this point on states that, you know, server get info asks it has to pass in some information about the client. So maybe this has got some baked in client information in it. But who knows? Who knows? Let's just shove that in. So server get info. What I'm going to do is behind the scenes, I'm going to get a snip tool, and I'm just going to copy that over to this off screen so I don't have to flick back and forth between the two. And then I can type that in. All right, so server get info is the start, and that ends with a hex 02. Control-Alt arrow keys. Yes, it is to move between VMs, but I don't think it actually works in my... Ah, it does. Oh, that's glorious. See, that's why I stream, so I get to learn from you guys. Thank you very much for that. Who is that? That was Calibwam. It's really hard to read on my screen. AJ streaming bacon. Yeah, bacon. God, I love a bit of bacon. Okay, after that, what do we got? We've got the number 2, followed by hex 01, followed by the word data. After data, we've got another hex 01. And then we have a 0, followed by another 01. Now I like to just break it up so it doesn't all look like one long horrendous string. So after 01, we then have, we've got data 0, 01, then we've got a null byte, and then we have a capital H. Really? Capital H followed by hex 09, followed by a lowercase h, followed by a hex 81, hex 1b, hex 03. So that is basically the body of the packet. So if we'll say the packet is the header plus the body, and then from here we're just going to go s.send body, and then we'll go response equals s.recv. We'll just say give us a bunch of data, and then I'm going to print it out in 2 different ways. We'll go response.encode hex, and we'll just basically print the response as is. We'll see how that goes, hey? All right, so what happens when we run this? Of course, we've got to check for updates to phone tools behind the scenes. You have the latest version, opening connection to blah, done. Send body does effectively nothing. Not really sure what the go is. Okay, so we know that well, technically this body should actually be valid, right? Server get info, hex 02, got 201 data 0. I'm just checking, cross-referencing this again against my screen capped doohickey. Data 01, hex. So it looks like it's actually hanging. It's not like it's even getting a response. So what have we got here? What are we waiting on? We're waiting on the receive. We're waiting on the receive. So what are we missing? What are we missing? So we've got 7519 BAAB. We've got 3. Did we pack it the right way? Maybe that's the problem. Maybe that's the problem. Have we actually packed this correctly? Maybe I'm just assuming that the packing is around the right way. Am I missing something, folks? Someone tell me. It's body packet. So we've got the header, that's body. Thank you. Thank you. Who is that? That's body packet. Who said that? Who said that? Justin, of course. Thank you. I should be sending the packet, not just the body. Let's try that again. Woo! Look at that. Okay, so that clearly worked because we ended up with a response, and that response contains some information about the server clearly. So failed train, version, agent ID, status code, server info. Awesome, awesome. Thanks, Justin. Yep, I did read it. I'm just stupid. Okay, so the packing was correct. We just had to send it. Okay, so what we've got here is we've emulated the ability to connect to a server and ask for some stuff. That's pretty much where we've got to. So that's useful. At least we're outside of the context of the client now. Obviously, this doesn't mean that we're really getting anywhere. We're just sort of creating what looks to be a fairly crappy client that we could possibly attempt to use to fuzz things or make some logical guesses to see if we can own some stuff. And that's basically the path that I intend to take. I'm not going to sit here and fuzz wildly. I'm going to spend some time now debugging and looking at some code to see if we can sort of narrow down an area of functionality that has a bug in it. Yeah, so basically what we want to do now is behind the scenes, we'll minimize this just for a second. Now, we have a bunch of binaries inside Sync Breeze Enterprise bin. What I might do is just allow file extension view. So we've got a bunch of these DLLs. Obviously, it's making good use of the Qt GUI libraries. We've got this syncbrc.exe and syncbrn and syncbrs and syncbreeze. I actually don't know what most of these things do, but one of these behind the scenes is running the server. So let's just have a look at services. Let's have a look in here. Okay, so the service is the syncbrs.exe. So maybe what we can do just to begin with is we'll open this up. We know it's 32-bit because when we looked at the about earlier on, it said that it was a 32-bit application. So let's have a look at syncbr. It was S, wasn't it? As in S for service. Yeah, of course, I can't read it from there. We'll just chuck it on the desktop. Alrighty. So I have a copy of IDA Pro, but I haven't updated to the latest version, and I don't intend to do that anytime soon. So if you've got a copy of IDA Free version 7, you probably won't be able to analyze this binary because it's 32-bit. But the old free version should be okay by the looks. All right, so one of the things that I'd like to do, if possible, is avoid running this thing as a service and attaching to the service. And instead, it would be great if we could run this locally. And it turns out, thankfully, with this thing, you can. So this is the entry point to the service. And the first thing that it calls is this init system function, right? Now we won't dive into this init system function just yet. We might just cruise past, but you notice here that straight away, let me just turn on line prefixes because I like to see the addresses. Straight away, we're starting to compare things to hard-coded strings. Now, just doing a bit of a gander at this line here at 2D4, you can see that we're comparing something to -console. And I think it's pretty fair to say that you can make a little bit of a logical conclusion or a leap of faith that at this point it's comparing maybe a command line argument to the word -console. And if you look just a little bit further up, you can see it's pulling argv into edx. It's using edx to extract a pointer. And as you can see, it puts the pointer to console in EDI and then basically does a comparison between the value in argv and the value stored in this location, which is -console. So I would assume that, or I did assume at this point, that if we hit stop, and we can even run this as an administrator here, so we go see program files x86. That feeling when you're constantly toggling numlock. Program x86 sync breeze enterprise bin. Okay, so we should be able to go and run sync BRS console. There we go. So just having a quick gander at the entry point of this source, we can see that if we pass the word console and as a parameter, then we end up with two different code paths. One runs things as a service and one does not. Now this sub here, you can see invalid command line, it's checking a bunch of other stuff. Otherwise it goes ahead and does some other magic. Whereas if you go down the other code path, down here it does a bunch of service related shenanigans, which we won't dive into for now. Okay, so just to confirm that that's actually running, what I'm going to do is go back here and just rerun this, and let's see if we see any. No, we don't. We don't see any extra logging on the command line, which is a little bit frustrating. Okay, so yes, Justin, thank you. I did know that escape goes back, but part of me wants to at least use the interface in that regard so people can see how I'm navigating around. And that's also part of the reason why I'm habitually sort of going between VMs using the tabs so that people can see what it is that I'm doing, or at least trying to do. Okay, so what are we going to do at this point? So we know that, that we don't need to run this as a service anymore. We can run this from the command line, which means we can spin it up in a debugger. So that's what I'm going to do now. There we go. I hate obscure errors. So this is the new WinDBG that you can get for Windows 10. I don't know if anyone out there has had much of a chance to play with this, but you know, it's got quite a nice user interface, and so for the sake of this little exercise, this is the version that I'm going to be using. I'm sure it'll come with some things that I really can't stand, but you know, yeah, got to put up with the good and the bad, I guess. So what I'm going to do is we'll go launch executable advanced, because we're going to need to pass in arguments. I'm going to browse to the binary that we want. Files, let's say 6 sync breeze enterprise bin sync BRS. Pass in console. We might even leave the start directory the same. Target bitness will just auto detect. We're not going to worry about time travel debugging or anything like that for now. But anyway, we'll launch this and hit go. And off she goes. Now I have only just fired this up as well, so as far as debugging symbols are concerned, I haven't downloaded any or cached any. So there may be something along the way that causes some symbols to download, which means things are going to take a little bit of time. All right, so what do we got? It's clearly working. We've had no problems with the connection. We've got data back. Okay, so we're running basically under the context of WinDBG. Now, so what I'm going to do at this point is do what I did last time when I first started nosing my way through this code, and looking for calls that accept data on a socket. And the reason why I want to do that is because I effectively want to narrow down the point where data that we control is actually being handled in memory. Got some discussion going on over here. Can you tell me, guys, if IDEA has a debugger or not? Yeah. Well, IDEA does have a debugger. In fact, let me show you how you can actually do this. I'll close this off. And we'll go back to IDA. You can choose a debugger. You can choose a number of debuggers. So you can choose a local Win32 debugger, you can choose WinDBG, you can get it to connect to a GDB server, so it has it all, it does have it all baked in. If we choose local Win32 debugger and go to options, where is it? I can never remember where these options are. Here we go. Please read carefully. You might end up running an application that's going to screw you. Yep, that's fine. So you can see that just basically stopped straight away. And the reason why that stopped straight away is because, oh, here we go. We're doing the symbol thing. Waiting for something to finish crashing at least. I know we'll regret this. Oh, IDA crashed. How good is that? Yeah, desktop. Let's go back in here and do that again. Anyway, in theory, that's effectively what you should do, is attach, you can choose one of your debuggers and hit go, and it will actually step through just like anything else. That'll teach me to not drop that menu down. Yeah. So I've never actually I've never used, like, for example, the WinDBG debugger. I'm pretty sure there's an option in here. I just can't remember what. Ah, debugger. Here we go. Debugger options. So you can get it to do a bunch of stuff. But you can also specify process options, parameters, console. So when you hit go, the reason why it says that it can't find WinDBG is because it's actually not used to, okay. It's not used to looking for this Windows 10 version of WinDBG. So let's try a local Win32. There you go, look at that. So we can see that it's actually running now in console mode. And behind the scenes you can see it's actually doing bits and pieces. So this is effectively now functioning exactly the same as WinDBG. But yeah, I don't know. I'm not a fan of using IDA for debugging in this manner. But just to prove that it is actually functional, there you go. We're still getting data back, and it hasn't crashed. It's still running. But what I want to be able to do now is I want to break on certain functions. Now, for those of you who aren't familiar with either socket-related code or haven't done any development of their own in the past, typically behind the scenes there will be in the case of a server, there will be a number of functions that are called in order to set up a listener. So a socket will be created, the socket will be bound to an address. We will ask the operating system to listen on that address, and then we will invoke a call to a function called accept, and we'll say, hey, using this listener socket, block until we receive a client connection. And when that client connection happens, we should get a socket handle out of that call that says, here is the handle that allows us to kick off and talk to the client. What typically happens is, in a Unix world or a Linux world, you'll have, as soon as the accept returns, the process will fork or create a new thread, but usually you'll see forking, and that forked process will go off and handle the client connection, and the parent process will just run in a loop and accept again. In Windows, we kind of don't have the equivalent of forking, so usually it's kick off a separate thread and let another thread handle that. So at this point, basically what we're looking for is there a call to accept somewhere in this? So what I'm going to do is I'm just going to stop the debugger here, because I don't like I said, I don't like using IDA for this, so I'm going to use WinDBG. We're going to go back here, use these default options that we had from before, and kick this off again. Right, so because I'm actually a horrible noob when it comes to dealing with WinDBG stuff. I'm going to have to refer to a number of cheat sheets that I've got lying around. So what I want to do is we need to be able to load a breakpoint, set a breakpoint on a function call. So what I want to do is be able to BP breakpoint on, let's say, w winsock 232. I think that's what the DLL is. Exclamation mark accept. Now I'll be surprised if this works. Downloading symbols. Did you see that? Currently downloading symbols. Let's see if it is actually downloading symbols. See symbols. Doesn't look like it is, does it? Ah, okay. So it looks like we do. Breakpoint. So we have it locked. Okay, that's pretty cool. So except will tell us whereabouts in the code that call is being made. But in order for this to go, we'll have to actually hit the go button, and nothing happens. So maybe there is actually no call to accept, but I'm pretty sure that there is. Just give me a minute, let's have a look. So this should have broken prior to any sockets being listened on, right? So maybe we can see here that we've got WS232. That's actually loaded. Functions are definitely here. There you go. WS32 accept. It might be calling WSA accept as well, if there is such a function. Let me just confirm that. I was under the impression that WSA accept actually invokes accept behind the scenes, but I will check that by looking at some documentation. The WSA accept function conditionally accepts a connection based on the return value of a conditioned function, provides quality of service flow specifications, and allows transfer connection data. I wonder if that's actually used. Now, what's probably worth looking at as well in here is what other libraries are actually being used, because you can see here there's syncbrs is the service that we're using. There's libpal, libsync, and libspp, and each one of those is in here: libpal, libspp, and libsync. So these are all dependencies that come with the software. So who knows where this functionality currently lies? We need to figure that out. OJ, where's your level 24 climbing video? Maybe I'll post that in a different stream, but I'm not going to do that now. Yes, let's not go there. That could be embarrassing. Okay. Anyway, are there any questions at this point? Like, as you can tell, I'm sort of floating around and I'm kind of lost, but I have an idea of what it is that I'm looking to do. Maybe instead of breaking on accept, we can breakpoint on recv, because obviously it's going to be receiving data. So we could go S232 bang recv, and there we go. We've got a breakpoint there. So let's hit go, and we'll go back to this VM, and let's just see what happens. The fact that that's blocked is a good sign, right? Boom. Okay, so this is interesting. So we've got a breakpoint on recv. What I'm going to do is just fire up the where are we? View. This is disassembly. Let's pop this up here so that we can see it. So you can see we've got a call to recv. I'm just going to step over this until the function returns. Oops. I'm going to keep doing this until the function returns. There should be a ret call some point soon. It might even be there should be a, what's it called? It's like Shift F11 or something. Here we go. So check this out. I pressed Shift F11 and basically said, pop out of the function, basically let the current function execute until the end and then return. So we end up in this this area of code here, which is interesting. You can see that we're inside a function called SCA win file, by the looks, inside the libpow DLL, which is interesting. So obviously the stuff that we're looking to muck around with and maybe understand a little bit better is not in the .exe but in one of the dependent DLLs. Doesn't IDA have a list of functions used inside the application? Yes, it does. But it'll only show the names of the functions that are known locally inside the file and inside like known DLLs, but not unknown ones. And it doesn't show sort of recursive dependencies either. What other files are there outside the bin directory of that app? Okay, at Wolf, let's have a look. So outside of bin, you've got what looks to be some kind of binary configuration. Let's see what this looks like. $12K of what Notepad believes to be Chinese. Pretty sure it's not actually Chinese. So there's some configuration. There's an empty documents folder. There's some details of this HTTPD. So, okay, so this looks like stuff that's served by the HTTPD process. We've got some plugins. Okay, so this FLX stuff might be some kind of custom scripting thing, or maybe it's part of Flash or something like that. Yes, the lack of, look, to be honest, the lack of Vim is almost criminal, but as you know, I've literally just rebuilt this VM, and so I haven't had the chance to install it. So don't talk to me about Notepad++, Will, otherwise, you know, we'll get into editor wars. Reports appears to be empty. There's this license file. I can read this out to you, Wolf, if you prefer, but I think that will send us all to sleep. So it looks really like the only thing that's of interest would be the files inside this folder. You're a funny man, Justin. You are a funny man. Yes. Do shut up about that in case Microsoft wants to go and buy it. All right, I'm going to spin up another copy of IDA, and we're going to disassemble libpow. Yes, I know. Whatever. Save. Okay, I'm going to assume there's quite a bit of functionality in this. Cool, I saw the HTTP directory and wondered if that actually contained a server. Yeah, it looks like it's just content by the sounds of it. They're trying to be sure they added Linux line in this. Yes, they are, Tom. And about bloody time too. You would think that was rocket science, right? Okay, so according to WinDBG, we should be inside a function called SCA win file. So let's see if we can discover that. Where are we? SCA win file. Operator equals. So we've got SCA win file is the name of the class. Operator equals is the name of the function. I'm not sure. It does. Here we go. Now, when I first started looking at this code, I thought, why on earth is there a recv call at this point in the code? So you can see we call this MD5 starts. Like it looks like there's a bunch of function pointers or something here, and we end up calling one of them inside operator equals. Now, if you've ever written C++ code before, it's probably fair to say that you should know you should never do things like network calls in an overloaded operator. particularly in something like WinFile. So without really understanding the code to any length or any depth, this does seem really obscure, a very, very strange thing to be doing. What I want to do though is line this up so that we can see more things side by side. It'd also be nice to see the registers. So I'll plot these in here. Where did there we go. So let's move that over there like that. Move this over here so we can see the debugging as well, and here's the registers. Alright, so the reason why I'm interested in looking at the registers is because as we progress, I'm obviously interested in seeing whether some of the values that we have specified in our header magically appear or somehow get used somewhere. So just make these windows a little bit easier to digest. Given the resolution that I'm using, everything's a little bit cramped. Saw a vid today, the MS team dropping off cake to the GitHub team. I almost walked in the Oracle office. That would have been pretty funny. All right, so have a look here. Here's the first thing that I noticed. The result of this call that we've just returned from, that behind the scenes had invoked recv, which I assume is exactly what that function pointer was. The return of that call is hex 18. So that kind of that's not a huge number. And when I first started looking at this, I thought, oh, how many bytes did we actually send at various points? So hex 18 is what? So that's 16 plus 8 is 24 bytes. So that's basically 6 lots of 4. So as you can see here with the header, there's 1, 2, 3, 4, 5, 6. 6 lots of 4 bytes, right? So is that coincidence? I don't think so. So what we're seeing here is that this call to recv returned hex 18 bytes, which is exactly the length of the header. So somewhere in memory, the header should be visible. So I'm just going to leave that next to the disassembly window. Because somewhere in one of these pointers, I would assume maybe, let's have a look at ECX. Video $ECX. Is it at? Never remember. No. ECX 9C. So it's not that one. EDX. So you can see I'm not even bothering to try and figure out the parameters. I'm just guessing. So what I'm looking to do now is to see if I can stumble across the area of memory where the stuff that we've sent has actually been stored. And you know, it's easy to get exciting. You see, oh, there's a 1 and there's a 20 and a 0 and whatnot. But I don't think this is actually the data that we're looking for. So what we can do in future is we can actually set a breakpoint here, and we can analyze the contents of these functions. Actually, it could be ESI. No, it's not ESI. All right, so what I'm going to do is we'll take a copy of that, and I'm going to go BP on that address, and I'm just going to let this run. Now I'm just going to hit go. Now that will keep breaking for now on the recv call. And so when we go back to the other virtual machine, you can see that this is finished. Now what I'm going to do is I'm going to rerun this, because behind the scenes we should actually see a breakpoint on the call, right? Which is cool. So we know that recv, according to the documentation, let me just quickly go to it. I know that the Googling isn't happening on screen, but I'm not doing anything particularly interesting. The recv function on Windows states that the first parameter is the socket handle, the second one is the buffer, the third one is the length, and the fourth one is the flags, right? So push 0 here would be the flags. Push ESI is the length, and as you can see here, ESI over here contains hex C. ECX should contain the buffer and EDX is the socket handle. So with ECX pointing to the buffer, this should read in, this function call should read in hex C bytes. So what I'm going to do is I'm going to disable the call to recv and just step straight over it. And then the memory area, which you can see is ECX has actually changed. I should probably have not bound it so that we could actually see. But the content, the return value of that call looks to be completely different. So you can see there's zeros. It doesn't look like it's done anything like we would expect. So I'm going to hit F5 because by the looks of it, this function could well be a pivot point for a bunch of other functions. So what I'm going to do is I'm going to keep pressing F5 until the length that we're looking for, which we know is in ESI, matches the number of bytes that we're expecting to see come out. And as you can see here, hex 18 is the current value of ESI. That's the length of the header. That's what we know is going to be the first recv call. So my guess is at this point that this function, oh, there you go, look at that. It's calling WS232 recv. I hope that makes sense.
Music is just a series of altered patterns. Musician creates the
Cool.
patterns.
No one's asking questions. I'm going to assume we're all good. So this recv call is going to result in whatever is pointed to by ECX to be the buffer. This is the address of where the data is going to be stored, we hope. So going back here, we press F10 to skip over. And here did that actually change? Maybe it didn't. I don't think it did. I can't see anything that resembles the data that we sent. So anyway, let's continue, because maybe we end up back at this call again, and we've got another recv call. Now this recv call this time, you can see how it says ESI is 20. Now that again is interesting, because recv length is 20, EDX again points to 414, so that's the same socket handle as before. FFA1C is where this is getting written to, so FFA14 is here, so we expect this data to change after this call. Doesn't look like it's getting written there at all, does it? I didn't see anything change. It's still all zeros. So I'm just going to do that again. I can't see any data in here being written. Can you guys? I'm guessing not, given that you guys aren't complaining or highlighting anything. The whispering in the music was kind of annoying. Has it stopped? Was it distracting to the point where you couldn't understand what I was saying? I can turn the music off if you like. You're winning at life, my friend. So let me do this again. I'm going to kick off our little script. What I'm going to do is make sure that I'm not doing anything silly with my assumptions. So here we can see this time ESI again has, give me 18 bytes. EDX, which is the socket handle, that looks different, but that makes sense because we have a different socket here. And again, ECX points to a buffer, and it looks like this buffer is on the stack somewhere. That's what it looks like. So it's definitely there, right? We can see that address that's currently in ECX says right to this, and this should be pointing to recv. Right? Let's just step into this time, because at this point, whatever's on the stack should effectively map to those parameters. So let's have a look at the stack. I'm going to shove that in here as well. So the stack, this has only got like a call stack. I should probably just show another memory window. I wonder how you view multiple memory windows in this thing. I guess I don't know. I should probably still be using the old version. So anyway, we know that as far as the call stack goes, we're definitely inside recv. You can see behind the scenes here, there's this operator equals being called, and that's actually being, again, behind the scenes invoked by some custom Windows heap allocation functions. Now, I don't think we really need to go into that area, but the important thing is that the call to this function was being made and passing in these parameters which pointed to this area, and one would assume that the result of that function call is writing data to this area, but I still can't see it because I can't see ABBA 1975 appear somewhere in memory around here, unless any of you guys can. It's definitely around here somewhere. Just a minute. Okay, let's just see what happens when we follow the code. Okay, I'm just going to run through this a little bit. And we'll just keep an eye on registers to see where things are pointing. So we've got a value here in EDX that looks similar. Aha! Have a look at that. So EDX contains an address that points to 4 bytes immediately before the buffer that we've sent, the first 18 bytes. See that? 7519BA80300000 and blah blah blah, and there's 20 right there. Right? So in our disassembly, EDX points to that location. Now we're actually about to write a value to EDX, which is the size. So inside memory here, we should see the value of hex 18 written to those 4 bytes. That's what that says, right? ESI, which is hex 18, should now be written here. But I can't see that change. I wonder if there's something in here that's there we go. So it looks like the view isn't actually refreshing unless you force it to refresh, which is quite interesting. Maybe there's some setting that we can configure somewhere along the line that will allow that to update in real time. Oh man. Someone needs to ban Justin. The ABBA jokes are unacceptable. Okay, so what we've got in memory now is we've got a very simple map. We have 32 bytes in memory now. We have this first 4 bytes that specify the length of the header, followed by the header itself, right? Actually, it's not 32, it's slightly less than that, it's 28. So we're missing that stuff there is the actual header, yeah? Is that what we had before? Yep, 20 followed by 4 zeros, okay. Yep, so it's that and that. Okay, so there's the header and there's the size of the header there. Okay, so immediately after that, what are we doing? We test the return result, which looks like a flag, true or false. Did we receive a header, yes or no? And we returned a value of 1 to the caller. And it looks like we're in a function called net transport wait for message. Okay, so if we go back to IDA and we have a look at, let's go net transport wait for message. What do we got here? So this looks like some kind of initialization, SCA transport, read buffer. Okay. Let's just quickly add addresses again, and we'll be able to see that we're still in libpal 00A590D. That doesn't look anything like what we're looking at, does it? The addresses are not the same. We got any discussion? Oof, that's painful. Come on, OJ, take a chance on me. Justin, I swear I'm gonna take you down. This is the type of assembly where destination values are the first operand, right? So we're looking at Intel syntax, not AT&T syntax. So yes, the destination is on the left-hand side most of the time. For some reason, I can't read AT&T. Never have been able to read AT&T. So in my head, I always assume that the destination is on the left and the source is on the right. And every now and then I'll see AT&T syntax and I'll do everything I can to change the format so that it's back to Intel because it just does my head in. So yes, Tom, I hope that answers your question. Tega OW, hey, what are you doing today? We are currently in the process of attempting to find and potentially exploit a vulnerability in a server called SyncBreeze Enterprise. And right now we're at the point where we're just sort of narrowing down the area of functionality that is responsible for receiving messages off the wire. And we're going to see what we can do with the content of that message in order to try and get it to break. I hope that answers your question. Right now we're working out how the network comms work. Exactly. Yeah, we do know there's a bug because on exploitdb a bug was submitted. We just know that somewhere in the code somewhere there is a bug, and we're basically just trying to track it down by flying by the seat of our pants, effectively. And right now we're just looking at network transport code to see if we can stumble across anything, basically. There could be, I don't know, there could be other issues, but we at least know that there is something that breaks. Now, here's where it's starting to get a little bit more interesting. Let me just widen this window a little bit. Check this out. Compare this value to, mamma mia, ABBA 1975. So it's currently looking for the magic value of ABBA 1975. Excuse me. So is there something in here that does the same? Ooh. Compare. Look at that. Is that the same thing that we're looking at? So test, jump short, compare, jump short. There you go. Test, jump, compare, jump. MobEx, dword pointer. So there it is. This is the area of code that we're looking at here. So we have this comparison. This line here is exactly what we're seeing in WinDBG. Right there. So what happens is if it's unable to locate it, it buggers off somewhere else. So when we've done the comparison, you can see here, branch 0, we're not taking the jump, right? So jump if not equal to. So if these two values are not the same, then we jump. And according to IDA, you can see we'd be taking this leap elsewhere, and we won't bother won't do any more. Whereas according to this, we're going to actually, ooh, look at this. Okay, so we do a comparison. We say, hey, are the first are the first 4 bytes this magic ABBA 1975 value. If it's not, then bugger off. If it is, the next thing that we're doing is we're comparing, or we're pulling out the size and comparing that to hex 400. That's interesting. This looks like a hard-coded buffer size, at a guess. Let's just see what happens when we set through, because you'll see here comparing EAX to 400, EAX is 20. Okay, so if we go back to our exploit, with those people paying attention at home, we passed hex 20 in here. Okay, so if we're passing in hex 20 at this point, then we clearly have control over something. Whoops, I pressed the wrong button there. We have control over what this thing is going to do next. So it's basically saying, let's go back to the IDA view, it might be a bit easier to digest. If that value is below or equal to 400 hex, then where are we going? 156, then we go down here. Otherwise, we go and do a heap allocation. If we don't do that, then EBX points to somewhere on the stack, whereas here EBX points to somewhere on the heap. Righto, so if we specify a value greater than or equal to, greater than 400 hex in that box, then we take this branch, it gets the heap for the current process, it allocates memory on the heap using EAX as the size that it wants. Once it's got that, it makes sure that it's, what are we doing? Compare EDI. EDI is EAX, so it's check. It looks like it's just doing a basic pointer check. And then it stores the pointer in EBX. So at this point here, right, at this point here, it's saying do another read buffer call by the looks using EBX as the buffer and EAX as, what would it be? The size. And ECX is something else. Let's have a look at what that is. I would assume that this read buffer call is effectively what we had called previously, which ended up being the reason why we ended up here in the first place. So let's just have a quick check. Just having a quick scan, so I could be wrong. Net message. It looks like it's supposed to support encryption as well, given that we're seeing things like AES listed in the code. Yes, Taiga, it's definitely assembly code, this. 32-bit x86 assembly code. Okay, so let's just follow this, step through this a couple more times. So EAX we know is hex 20. And at this point, EBX now contains what looks to be a... Did we just jump to a completely different area of code? I feel like we're in a completely different area of code now, but maybe I'm wrong. ECX, ESP18. No, we're not. We're definitely in the same area. So that's this location here. EBX and ECX. So EBX points to A1C, which is all zeros. Whereas ECX points to 9FC, which is also all zeros. That's like immediately before the buffer size. So what are we doing now? We're calling read buffer again. Now I will assume that read buffer behind the scenes is going to, what is it going to do? It's going to read data off the network again. So ECX points to, what is that? Let's see if read buffer has some read buffer. Here we go. So clearly this is a C++ object. This unsigned int, int. I would assume that that's the buffer. That's the buffer size, and this is the number of bytes that are read. So I would assume then at this point that we're making another call, and we will end up seeing, where are we? EBX contains the buffer. So that's where we're going to be writing to, A1C. A1C, I'm just going to leave it there. We'll force a refresh of this in just a minute. EAX is the size, and ECX, this area here, points to however many bytes were received. That would be what I would expect to see. I'm going to hit F10, but our breakpoint may get hit here. There you go, it is getting hit again. Calling recv, and we're passing in EDX, which is the socket handle, ESI, which is 20, and ECX is the buffer size, as the pointer to the buffer, as we thought. So let's step over that and pop out of that function call as well. Did that even work? No, it didn't. We'll just keep going until we call ret again. Ret. Test EX. Okay, so did that succeed? Yes or no? Yes, it did. So this is just returning again. Okay, so here we go. We've called read buffer, and the result is true. So that means that whatever's in memory here, I'm just going to do that force refresh. Here we go. 53455256. Pretty sure we know what that is, right? So we should be able to go in here. I think we go, is it DS? DA. There we go. So DA says like dump ASCII string, and we can see server get info to data 0, which is basically the body of what we've sent it. All right, so fair to say then that, where are we? Let's go back down here. Is this where we were? I'm pretty sure it was. Net transport read buffer. Okay, so read buffer is not what we're looking for. So here we, once we've got to this point and we know we're receiving a message that's small enough, we will store that message on the stack, otherwise we'll chuck it on the heap. Now, what happens after this? It looks like, there's some decrypt functionality going on here. All right, so once we've read that, we basically check EAX and we go, is it 0? If it is, we go to BC, otherwise we end up here. And it looks like we're going to do some kind of accounting. So let's follow it through. It's a bit easier to follow in real time when we can look at the content of registers. So we know that that succeeded. And so here we're going to pull out a value. So EDX contains 20. That's how many bytes we read, I would assume. And then clear out ECX, and EAX contains hex 38. Because, what are we doing? We're just adding 18 to this. Okay, so that we know that the header is 18 bytes, hex 18 bytes, I would assume. and therefore EAX should contain the full packet size, which is 20 plus the header byte size, which was 18. Now what are we doing? We are adding that EAX value to a pointer offsetted at this location, plus 270. I don't know what this stuff is. Let's have a quick look. What is this? Bad food, bad food. It's plus 270 hex. Really? That can't be right. Guess it is. Okay, sorry, we're looking in the wrong segment. Alright, so this looks like some fairly trivial accounting stuff that we might be able to just skip over. I'm just going to zoom past this for a bit and let's see. Here we go, we're looping. We're looping. You see how we've got EAX as our loop counter and ECX is being used as a loop stop. And that contains hex 1A. We've seen that before, right? Here. How interesting. So, this little loop here, if we look at that in IDA, we're doing this. Compare EAX, ECX. So we're basically doing this. We are copying this little loop here is basically copying byte by byte to a different location, right? Move signed value from this location. So read that out. Oops, sorry. Loop. Okay, let's just quickly monitor what this is doing. So we read 45. Now I would assume that going back to where we were before, can we go back? It's 53, 45, 52. There you go. So we were up to the second one because EAX is 1. That's offsetted by 1. So instead of looking at 53, we're looking at 45. So why are we doing this? That's reading into EBP the value. So it looks like, given that this is looping for the entire length of whatever it is that we've given it, that is ECX contains 1A. We've told it to do this so many times. It's going to loop through, and eventually, once it's broken out of the loop, which is at this location, then EBP contains null. So that means, based on what we've got in our payload here, we have at 1A, which is however many characters. 1A is 16 plus 10 is 26 characters in. There's got to be a null byte. So that there looks like a null byte. So that must match whatever this value here is. Needs to match ESP plus 34H. 34H. What is that pointing at? ESP plus 34. ESP contains this 9E4. Okay, 9E4. Right, what is that? plus 34. Clearly, I'm doing something wrong with this math. Just a second. FAA18. There we go. Yep, so there you go, there's the null offset. So whatever this is, that has to match whatever the byte at the end of the payload happens to be. Okay, so that's kind of interesting. So we need to specify in part of our payload here, we need to say that, where are we? That the header maybe I'm reading this wrong, but it looks like it's doing some kind of correlation where a byte inside the body has to match a value in the header. So it's like this value here says whatever this last value in the header is needs to match a value inside the body at a certain offset. Is that what you guys are seeing? Yeah, so I'm pretty sure that's what's going on. So maybe what we could do here instead is maybe we can start mucking with our payload a little bit. Just to see how it's actually responding to things. We'll continue reading, and then what I'm going to do is I'm going to modify the payload a little bit that we're sending it, just to see what values are starting to come out of the other end. And I think that will help us understand things a little bit more. So anyway, it's comparing whatever EBP is at this point, which was null, and based on what we were seeing in IDA, we can see that it's looping through from the pointer at the start of the buffer through ECX times, ECX being 1A, which is a value we gave it. So from the beginning of the payload up to 1A bytes, we should see the value of null, because that's what was offsetted at that point, being the last byte in the payload. So there's something going on with accounting to make sure that the last byte in the payload is the same as one that's specified based on the offset that we've given it. Which is just a little bit strange. And here we're sending, what are we doing here? Wait for message. Ooh, here we go. So now we're calling deserialize. Okay, well that can't be a bad thing. So it's taking the message that we've given it and it's deserializing, I assume, into a buffer at EBX. We'll skip over that for now. Now EDI contains null, EAX contains 1. If they're the same, which they are, then we jump out to make sure that EBX is 1, which it is. That jumps again. Okay, what do we got now? EAX is 3, EBX is 1. Now that 3 must have come out of our payload as well. I think there was that's the first thing that we gave it. So there's definitely some values in here that we control reappearing. And then it looks like we're going to respond with an ACK message. Oh, that's interesting. Because what we can see here, when we did the original call for this, we seem to get this first response, which looks like what they're calling an ACK message, this 40. 40 byte thing may well be an ACK message followed by some content later. Where is it? There you go. There's the actual body of the response. Okay, that status code, server info, host name, version, agent ID. Okay. All right. Look, I'm just gonna stop it there for a minute, and we're gonna go to our header, and I'm just gonna muck with some stuff. Now, rather than break everything, I'm gonna duplicate what we've got. So, righto, so what I'm going to do this time is, instead of specifying hex 20 here, let's just put in something recognizable like 55. Here I'm going to put 44, and here we'll put 22. Now I'm doing this just for shits and giggles, just to see where those numbers are coming through, because they should be a little bit more recognizable. And we'll just see what happens. Okay, so calling recv, and you can see that we are pulling that data out. There's 18, so again we know that we're dealing with the header. I'm going to hit F5 straight away. Here we go. So 55, it's expecting 55 bytes by the looks of it. So that's the number that we know we've passed in. We're saying this is the size of the header. So we might actually have to get smarter, because if we, where are we? Yeah, because that returns 20 bytes. That's basically saying, did we get what we expected? We're returning. Was it? No, it wasn't. Here we go. Now we're doing another call to recv, and this time the SI is 35. So this must be a second message. That's got nothing to do with what we've given it. Oh, hang on, I guess it would, because we've given it 20 bytes, it's expecting another 35 hex. So we do need to give it 55. I reckon that's just going to sit there and block. Okay, so let's cancel our exploit. So if we're giving it 55, and that's what it's expecting. In fact, you know what I'm going to do? I'm going to put this up to, well, we know that hex 400 was the upper limit to where the stack versus the heap thing was. So I'm going to put that up to that. In fact, let's start putting some variables in. So we'll call this max buff is 400. Okay. So we're going to pack that in the header just here. Max buff. But it also means that whatever it is that we give it, we need to make sure that the body has that many bytes in it. So let's go body plus equals. We'll just pad it with A's, as we like to do, times max buff minus however many bytes are already in the body. Okay, if that makes sense. So I'm just going to leave all of the other stuff that was in there as is. We might even change this back to 1A. And we'll change that back to 0, and we'll just change the buffer size and the content that we're sending in. Okay, let's just make sure this is still running without concern. Looks like it is. You guys got any questions? Are you quite happy entertaining yourselves over there? Foosball Twitch overlay would be awesome. Hey, we can play foosball anytime, my friend. Now the book this problem out of wants you to do this in basics. Alright, so we're going to skip this again. We've called the header. Oh, check it out. Here we go. There's the value that we've given it, 400. 400 hex. So it's expecting a full 400 hex bytes. Let's see. If it's done. EAX 400. So it has read the full 400. That's cool. So let's step out of this. It's not very quick, is it? Crikey. Yeah, I wanted a crash as well. I think we'll get there. We're just not quite there yet. Man, this is painfully slow, isn't it? So maybe what I should do is set a breakpoint there. It's better now that we're out of that function. So EAX now contains 400. Awesome. It looks like we are bailing out back to that other call, read buffer. That's successful. EDX contains the length. EAX is now 418. We stash that as we did before. ECX now contains, it still contains 1A. Okay, so here we go. We're doing that, what looks to be that loop again. Let's press F5 and skip over that loop. So we want EBP, which is null, to also be null at the offset that is given. And it looks like it's the same. Okay, so that's good. That's doing what it was doing before. Skip over there. Oops, wrong button. 10. Okay, so oh, this is interesting. This is interesting. Look at this. Test byte pointer at a particular offset 8. So we're comparing something that we've given it to the hard-coded value of 8. Okay, and jump if equal to a different location. Is that what that says? That doesn't make sense to me. Because ESP plus 28, can't type, plus 20, 1, 2, 3, 4, 5, 6, 7, 8 was 0. Oh no, sorry, it was 1. It was 1. So yeah, that's 10 hex, 20 hex, 28 hex. It was 1. So if we're testing and then it says jump if equal, I'm confused as to why this jump is being taken. Let's go back to IDA for a minute. Where are we? We are... What's the message? Prior to decrypt. Is this the function that we're actually in? I should probably check that. OJ, it's a test on a compare. Yep, that's true. So what is it? Logical and? No. Sub? Yeah. Sub. Anyway, if it's... Yeah, logical and. Okay. Ah, okay. So in other words, if that value is less than 8, or not 8, then we skip this decrypt buffer call. Okay, that's interesting. So this value that we're specifying here basically says if it's, was it equal to 8? If it doesn't equal 8, then don't decrypt. Which is interesting. So yeah, we should say offset to, I'll call it the check character. And I'm going to say that this is the check character, right? Always branch. Oh wait, JE. Yeah, exactly. JE kind of says jump if equal. Is that right? Yeah, right. Okay. I should probably validate. JE. So you take this and 5 form access based on that. Compare. Yeah. Okay. Is to test if zero flag is set. Right, okay, so when you test, you get a logical AND. Yeah, I'm a little bit confused by that. Anyway, the point is that if it's clearly, we're setting 1, which isn't the same as 8, and we end up skipping the decryption routine, right? So, where are we? And then from here, what are we doing? That looks like a pointer to something. And then we call deserialize. Now I would assume that if we just let this run, we're just going to get nonsense back. No. Really, this is interesting. So we can give it a buffer that's huge, and it doesn't seem to care. It still only parses the first part. Really, that's really interesting. Does that even make sense? I don't know whether it does. Okay, so header's definitely 18 bytes. You end up with value of 8 in this field means that you've got to decrypt. Well, obviously we don't know how to encrypt stuff, so we don't want to decrypt anything. Is the thing as check the agent ID? Is the 0 the check the agent ID? I thought that this last header value is the value of what we've effectively said is the end of the command buffer, which is this thing here, right? So even though we might have a bigger body, we may have way more characters after the fact. It's the character at this offset that it's kind of checking. Maybe what we need to do then, instead of this, let me just try something for a minute. We'll set the body to A's, and we'll. What are we doing? How? I'm just getting into let's throw some shit at this and see what sticks kind of mode instead. So we'll leave those first two fields free. I'm kind of tempted to like do this and point that, basically say that's the last character, and then we'll do this however many times. And then at the end, we need to add a null character so that it matches this check, right? Just different names for exactly the same thing. Cool. That's exactly what I thought, Stealth, which is why it was confusing. A conditional jump when zero flag is equal to 1, similar to Jenny and E and J instead. When flag is set to 0, Use diff depending on context. Yeah, cool. Okay, that makes sense. We've got a logical and. With logical and 8 and 1, we end up with a 0, so the 0 flag is set to 1. Okay, yeah, that makes perfect sense. So basically it's saying that if the value is not 8, then don't decrypt. That's perfect. Thanks, Stealth. That was very, very helpful. We probably should have dived into that before. Okay, so I'm just going to do this. I'm going to specify these two things as basically the same, and make sure that the values that are coming through are exactly what we would expect, just so that I'm not mistaken. Okay, so there we go. We're reading the header. Why do I keep pressing the wrong button? F5 is what I want. F5. Okay, now we're reading 400 bytes. And I'm going to step out of this. Step out of this function a lot quicker in just a sec. F9, F5. Okay, step out. Righto, let's just see what we've got going on here. ESI 0. Don't branch. Copy. Okay, that's fine. Okay, here we go. EDX contains 400. EAX is 418. That's exactly what we were expecting. Back to 0. So this is where we're going to start seeing that loop in just a minute, right? ECX, steward, test ECX. Here we go. So don't branch, which means, yeah, okay, so we're starting at 41, which is A. Righto, so what we need to do is we need to go to here. Right, so EBP contains hex 41. Okay, so I'm effectively off by 1, right? So what we should be doing instead of this, let's just swap these around. Let's do the header after the body. And what we're going to do is we're going to say because we're going to tie these two values together, let's go len of body, and we'll do that twice, okay? And then whatever that check character is, we basically need to pack whatever the last character is as an integer. So that would be body or len body -1. Does that make sense? Oh, I don't even need to do that way, do I? I can just go -1. So we basically get the last character of the body, cast it to an integer, and pack that as an integer to make sure that the values that we're checking actually match. Does that make sense? So, yeah, that's what I'm thinking. So we leave these two the same because we don't want decryption. Here I'm going to say we'll just we'll have a buffer length that is hex 400, and we'll make sure that the very last 32-bit value of the header matches matches the very last character of the payload. Does that make sense? I hope that makes sense. It makes sense in my head. I'm going to run this again. Please tell me if that doesn't make sense. I'll do a better job of explaining it, because that wasn't really sane. There we go. We're reading the header in again. I need to go down to this ret and hit F5. Okay, let's just make sure. There we go. This is the payload that we're reading. come out of this function. Okay, back to the loop that we were looking at before. Oh, I've even got a breakpoint here. Okay, so ECX is 400. And we're going through the loop now. So if I hit F5, we should be comparing EBP, which is 41, to hex 41. Perfect. Okay, so that did actually add it to exactly where we wanted to do it. Am I understanding correctly that the hex 1A is an offset into the body, which it expects to be 00? Close, Smash. The reason why it was expecting it to be null is because the value that we specify at the end of the header is the value that it's checking against. So originally, you can see the header here, we were specifying the last value to be a null. And so it's basically saying whatever we specify here as an offset into the body, the byte value needs to be the same as this value here. So now what I'm doing instead is I'm basically just saying this value is pointing to the end, and all I'm doing is taking the very last value of the body, very last byte of the body, and using that in the header, regardless of what it is. So as long as we give it the offset and we make sure that the value at that offset is what's expected, and we put that in the header, then it should come out okay. Worth making sure you still don't have an off by one issue. Yeah, it probably is actually. So let's do this. We'll add a B to the end, and we'll run it again. Now I'm not going to. I don't want it to go over hex 400 because I don't want it to be heap allocated. Yeah, it really is, Tom. I don't really know why they're doing it this way, but you know, developers can do. Oh! Did you see that? Whew. We've got a crash. Shabow wow. Yeah, okay, we've got an access violation. That's fantastic. EIP is actually 41414141. Wow. I love it when shit like that happens. Anyway, look, I'm gonna restart this. Let's not get too excited. Let's relaunch. I hope did I lose my breakpoints? Please tell me I didn't lose my breakpoints, because that's gonna be shit. I think I might have done. Restart. I bet you that loses all of my breakpoints, but we can easily get back there. Okay, so let's just do it again anyway. So we know that if we do that, then right, we have lost the breakpoints. But check this out. So what it looks like is we've overwritten a pointer, and it looks like it's adding a hard-coded value of 24 onto 41, and it's trying to dereference that. So if we got a crash before, I'm assuming, okay, I know what this is. Okay, so we've basically got an access violation, and the access violation looks like it's causing an exception, and then the exception handler is kicking in, and we've overwritten the SEH record. And so it looks like we should be able to cause the access violation to occur and somehow overwrite, control EIP through a typical SEH style exploitation mechanism. Does that make sense? Does it make sense? I hope it makes sense. It makes sense to me in my head, but I don't think I'm wording it very well. So, don't know what Splat's linking to, but I'll let you guys go and read that. Yeah, okay, well, the good thing is that, you know, effectively what we're aiming to achieve looks like we're going to achieve it. But given that we're actually at this point, I'm going to go ahead and say that our off by one error is not a problem. We don't have an off by one, but what we should probably do is is figure out some offsets. So instead of doing A, we'll use something else. Let's do this. Pwn.util.cyclic is it .cyclic Metasploit? Now I'm using the Metasploit cyclic instead of the standard cyclic because there's someone on in the chat channel right now that actually contributed this to Pwn Tools, right? Justin? Justin wrote this one. It actually uses this the Microsoft. Sorry, Microsoft. Microsoft must be on my mind thanks to GitHub. Cyclic Metasploit uses the Metasploit cyclic pattern to generate characters. So we can thank Justin for that because he contributed that. What is he saying? Yeah, cool. So we have 2 opportunities for EIP control. Yes, I think we do. So once we've figured out the exact offset of that, of 2 things, like I want to know the offset of the point that it's dereferencing, and I want to know the offset of SEH and NSEH so that we can go ahead with the exploitation path. And that's exactly what we're going to do here. So let's go max buff. I'm just going to go max buff and get rid of that character at the end. Okay, so I think that's the syntax. Let's just restart that. And off we go. Debugging is running. Right, here we go. Okay, so we have our first crash. And we have 63413187. Now, if I take a copy of that,
Pattern recognition.
Music is just a series of
I'm going to go body equals A.
anticipated resolution.
I'm going to say,
As you wait for it.
I'm going to call this deref offset. Pwn.util.cyclic Metasploit find, and we give it whatever the value is. The copy and paste didn't work. I hate virtual machines. Oh, I know why. Let's do that again. Oops. Gotta love Linux. There we go. Now we know that this added 24 in hex, so we've got to subtract that. Right, so that 87 will become something else. I'm just going to print that so we can see it in action. We're also going to need to know the offset of EIP at the point of the crash, so I'm just going to let that run and let's see what EIP contains. 33. Okay, so we should be able to get both offsets in one hit. Right. And there it is. Now I should probably no, utils main cyclic metasploit is the publish function. Oh, okay. You reckon it's just pwn.cyclic? Really? I'm going to leave it as is and we'll come back to that. So what I want to do here is go body equals A times deref off. So we go to the dereference point. We're going to add B, and then we're going to go body plus equals, we'll put C's in here, times, can't type, god damn it, we need to go EIP offset minus the length of body, and then body plus equals, we'll make 4Ds, and then we'll just add ease up to max buff minus len body. Okay, so all I'm doing is padding with A's until we get to the point where we're dereferencing, so we should see B's, then padding with C's until we get to the EIP offset, at which point we should see D's, and then that's just filler for the max length. So let's give that a spin and see what that looks like. Restart. This is exciting. I love it when things break. Yeah, log.info annoys me for a couple of reasons, so I just use print. But yeah, I know that it's there. There's log.info and log.error and, you know, a bunch of other bits and pieces. So, but yes, it's good to know for those people who haven't used Pwn tools before. There you go. 64 was the offset. Look at that. 42, 42, 42, 42. So yeah, we've definitely nailed the offset for the dereference. And 444. Oh, look at that. It's worked like a charm. It's exactly what we're looking for. I can get rid of that print now. Okay, so that was 1, 2, 3, 4. So we saw the B's and we saw the D's. Okay, which is fantastic. So there are the B's. EAX is there, and EIP 4444. So we've basically got exactly what we're looking for in our exploit, which is that's pretty crazy. That's pretty crazy. And what we should probably do at this point, let's tidy this up a little bit. We can get rid of all of this noise now, and we can even get rid of this response. Okay, so now we're in a position where we can actually crash this thing, which is very cool. I feel like we got there a little bit quicker than I expected, which is exciting. So what I might do is quickly restart this, and just for shizzles, let's have a look at that first crash again. So the first crash here, we are trying to dereference EAX plus 24H. But more importantly, whatever's there, we're trying to call. So, you know, given that's clearly an indication that we've overwritten some kind of possibly a virtual function pointer table pointer. And so it's using that initial pointer to look up a virtual function call before invoking it, which is what C++ tends to do. Which is cool because, I mean, technically if you were able to locate an address in memory where there was a pointer that pointed to it that was known, and then we were able to effectively subtract 24 hex from. So that would avoid the need to use SEH exploitation. So we can go down that path. We could, in fact, I'll probably look to do that maybe on another stream to see if there is a way that we can exploit just this call, and then we don't have to invoke the SEH handler. But for the sake of this exercise, right now what I'm interested in doing is getting code execution. So what time is it now? It's 20 past 10. It's 20 past 10. So Justin, you want to see registers. There you go, they're the registers. What is it, EX chain? Yeah. Okay, libpal MD5 starts. Okay, so it is definitely it's probably the same function pointer table that we were using to do the other calls before. Yeah, interesting. So NSEH and SEH. So obviously there's still a fair bit to do regardless of the method that we decide to choose to go ahead with at this point. So we can investigate whether or not we can determine an address in memory that always points to an area that we can somehow control or do something a little bit more interesting. Or we can do the classic search for a pop-pop-ret style SEH exploitation attempt. Is everyone familiar with how to do exploitation of SEH issues? We're obviously in a little bit of a world of hurt compared to the likes of the Windows XP days, because the stack isn't executable, so we would have to generate stack pivots and try and rop our way to glory. Nothing but a lurker. Okay, so you're not familiar with structured exception handler exploits. That's cool. What I think is probably worth doing then is maybe we can play around with things. So here's the reason why I'm a little bit hesitant, right? So if we were going to aim to control a function or call a function that either makes use of something that we control or somehow invoke a pointer that points directly to an area of memory that we control, then we've got quite a bit of investigation to do in both cases, because we're not in a case where we literally control the pointer. We actually control a dereferenced pointer. We need to have a pointer that points to something useful, and we need to know what that pointer is in advance. Plus, we're actually this is quite important. Let me go back to, oops, press the wrong button. This is the one that I meant to press. So these DLLs, these executables, are not compiled with safe SEH, and they're not compiled with ASLR, which is pretty interesting. What's interesting though is that the addresses that we're seeing here inside IDA don't match the addresses that we're seeing in here. So if we look at the loaded modules, so check this out. libspp is at 1022600. libsync is at 0b. libpal is at 00a6400. Now we're currently looking at libpal in IDA, and the address is different, but that could be just IDA giving it a different base address, I guess. Let's just quickly have a look at libspp. Yeah, it looks like it's got a similar base address, doesn't it? So 10159.586 libscp yeah, so it is, that libscp is in the same spot. This one does look a little bit different. Maybe try without SEHS. Yeah, that's nice. Diff base address because it gets different. Yeah, exactly. Even though ASLR is disabled, so that, like, these are actually all fixed. These ones here, and this one is too. Which is interesting. Now, what we haven't done is determine whether or not there are any bad characters in here. So obviously, in order to move ahead with a functional payload, we would need to determine which characters are good. Excuse me, and which characters are bad. But yeah. So okay, so it's now nearly 10:30. So we've done 2.5 hours. We've discovered the issue. We could spend the next sort of hour and a half, 2 hours diving down each of these paths and trying to get code execution. Or what we can do is we can pause at this point, and then maybe we can sync up in a couple of days' time at a similar time, quickly recap where we're up to, and move on from there. So the question that I have for everyone that's watching is, are you keen to push on even though we've been going at it for 2.5 hours? Or do you want to put it on ice for a couple of days and we'll come back fresh? Over to you. And while people are answering that, I'll answer. Here we go. Tom, did that mean that the app DLLs are safe for use as return addresses for EIP, or is that something that's stopping that? So what I'm saying, Tom, is that yeah, those DLLs that should have consistent addresses should be reliable to use for things like ROP chains and return addresses, etc., without the need to have a memory leak first. OJ's yawning, so my vote is call it. Happy to come back another day too. Can drink so much tea, call it a day and come back. I say another day. Yep, that's awesome. I'm thinking the same. Like if you guys wanted me to push on, I would go and grab another cup of tea and a big block of dark chocolate, and I would push on. But I think that it's probably wise at this point to call a halt. What I'm going to do is I'm literally just going to pause these virtual machines, and then we'll come back and we'll go over this stuff again. So if you guys are all cool with that, then that's what I'm going to do. So you guys all cool with that? Everyone's happy to move on? I'm going to assume yes. Yep, I'm cool. Awesome. Well, look, in the meantime, if there's anything that I've done or said that doesn't make any sense, like drop me an email at oj@buffer.io, or ping me on Twitter via DM. My DMs are open. Or through whatever other means that you happen to have the ability to reach out and contact me to talk about this stuff, please do. I'm happy to go in a bit more detail. I reckon the best thing for us to do is reconvene in 2 days' time. So maybe we'll catch up again on Thursday night, so 2 days from now. And in the meantime, if there's stuff that you would like to sort of recap, then ping me and we'll make that happen. So yeah, that's a good idea. By the way, in the background, I'm listening to SoundCloud. Guy Baroni, as always. He's got some really, really great tunes, and I love the backing track that he provides to this stuff. His music is being played with permission. I have got explicit permission from him to have his music on in the background. So big ups to that bloke for letting me do that. Love his music, and you guys should go and listen to him as well, because he's great. So I may drop an ABBA tune or two in the next stream, just for the sake of keeping the theme. An SEH primer would be nice. Yeah, okay, we can do that. We can go through and we'll talk about how SEH records are set up and why they're useful and what's required in order to exploit them in a couple of scenarios. So yep, I'm happy to do that. I might even grab a few links and share them leading up to that, so if people want to do some reading ahead of time, then they can do that. So yeah, okay, cool. Well, at that point then I will love you and leave you. Thanks to everybody who's come out to watch and listen, and who's offered advice and insights and picked up on my mistakes and stuck with me through my rambling and general sort of process of discovery. I hope that you've learned something from it. I hope I've certainly learned a couple of things from stuff that's going on in the chat, which is awesome. So much love to all of you. Thank you very much for paying attention, and I will see you on the tubes in a couple of days' time. Peace.